Hari Om. In the last video, we were discussing about non-polar substances and their behavior in the presence of an electric field. So let us continue that. Now we saw in the last part that in the presence of electric field, a net dipole moment is induced. A net dipole moment is induced in the non-polar molecules. Why? Because in the presence of electric field, the charges feel some repulsion or they experience some force. Positive charges tend to move in the direction of electric field, whereas negative charges move away from the electric field. So a net dipole moment has been induced. Now imagine if we increase the strength of the electric field, that is E. If we increase the value of E, the charges present will experience much more force, or the force experienced by those charges will also increase. So their displacement from the original position will increase. So the distance between negative and positive charge will also increase, or dipole moment will also increase. So we can say that the dipole moment is directly proportional to electric field. And since epsilon naught is a constant, that is permittivity of the space or vacuum, so we can say that dipole moment is directly proportional to epsilon naught into electric field. That is, if you increase electric field, the value of dipole moment that you are going to get from the nonpolar molecule will also increase. Now if we remove the proportionality symbol, we add equality symbol along with a proportionality constant. Here we choose the proportionality constant to be alpha. Here alpha is the proportionality constant which is called as atomic or molecular polarizability. Now from the equation dipole moment is equal to alpha into epsilon naught into E, you can get the value of alpha, that is P vector by epsilon naught into E vector. What will be the unit of alpha? The unit of alpha will be meter cube. Try to verify this by yourself. So now the non-conducting substances, may it be polar or non-polar, are called as dielectrics. Why? Why the name dielectric? You can guess from the word die means two and electric means something related with two charges. So what happens in the presence of an electric field, equal and opposite charges are induced on the opposite faces of a dielectric. So let us consider a dielectric material shown in this diagram, and when some electric field acts on it, the negative charges and positive charges are induced or generated on the inner faces of these dielectric material. Can you guess how? Let us see. Let us consider a dielectric substance, that is, there are non-polar molecules. Dielectric substances, let us consider it to be non-polar molecules. That is, non-polar means there are charges but no net charge or no net dipole moment. So I have just represented them by simple spheres. Now in the presence of electric field, as we have seen previously, that a dipole moment exists or a dipole moment is induced. How? Because of the elongation of these negative and positive charges. So there exists a dipole moment. Now if you consider the charges in the box here, the positive charges, 3 positive charges will cancel with the 3 negative charges. Similarly, the next 3 positive charges will cancel with the next 3 negative charges. So all the charges inside this dotted box become 0, and net, we can say that near the two faces of the dielectric, negative charges and positive charges are assembled, something like this. So we can say that in the presence of electric field in a dielectric substance, negative charges get accumulated in the left side and positive charges are accumulated in the right side. But now what will happen if you have a shield of negative charge and a shield of positive charge? There will be some additional electric field in the direction given by arrow mark. So inside dielectric there is some additional electric field. See, concentrate here. Outside the dielectric there is an electric field of E naught, and inside the dielectric there is an electric field of EP. Alright, so in the case of a dielectric material, if you take a dielectric material and place it in a region of electric field, then the electric field outside the dielectric and electric field inside the dielectric won't be zero. Let us see. Here you have three regions. A region to the left of dielectric, a region to the right of dielectric, and a region inside the dielectric. So to the left of dielectric, let us consider the electric field is E naught. It is the parent electric field, that it is the electric field that we are applying everywhere. And to the right of dielectric also the electric field is E naught. Inside the dielectric also there is E naught, but along with E naught there is another electric field that we called as electric polarization, or electric field due to polarization of dielectric material whose direction is towards left. So the net electric field inside the dielectric substance will be E naught minus EP, and its direction will be from left to right. So let's recap. There are three regions. Outside the dielectric, electric field is E naught, but inside the dielectric the electric field is E naught minus EP, and let us represent that by E. Now from here you can guess that in which region is the electric field more. For that you have to compare between E naught and E. Whose value will be larger? Obviously the value of E naught will be larger, because in the case of E, a quantity EP is being subtracted from E naught. So E naught is larger, or E naught minus EP is larger. Consider yourself, 8 is larger or 8 minus 2 is larger. Obviously 8 is larger. So E naught is larger, or we can say that inside the dielectric there is less electric field compared to outside the dielectric. So we can say that inside a dielectric material the electric field intensity decreases, and we are denoting the electric field inside the dielectric by E, outside the dielectric by E naught. Let us move to the next thing. The ratio of electric field outside the dielectric, that is E naught, to the electric field inside the dielectric, that is E, is called as dielectric constant. So there exists two types of electric field, E naught outside the dielectric and E inside the dielectric, and the ratio of E naught by E is called as dielectric constant, that is given by K. Alright. Now can you guess the unit of dielectric constant? What should its unit be? Let us calculate. The unit of E naught is the same as electric field, that is Newton per coulomb, and the unit of E is also an electric field, so it is also Newton per coulomb. So Newton per coulomb divided by Newton per coulomb, so no units, or we can say that dielectric constant is a unitless constant. Alright. Now from this equation, that is K is equal to E naught by E, we can get E will be E naught by K. What was E? E was the electric field inside the dielectric, and E naught was the electric field outside the dielectric, or the original electric field, and K is the dielectric constant. So if you have a material of dielectric constant 80, and if you apply an electric field of 800 Newton per coulomb, that is E naught is 800 Newton per coulomb, so outside the dielectric the electric field will be 800 Newton per coulomb, but inside the dielectric it will be 800 divided by 80, that is the dielectric constant. So inside the dielectric the electric field will become 10 Newton per Coulomb. Alright, so with this, let us stop here today. We will proceed to capacitors in the next part. Thank you.